So back in Algebra 2, did you deal with anything with parametric? And so this might be one of the first topics that you have not had at all before. And it's not particularly hard. So, first we're going to, anybody here in physics? Okay. So, physics, oftentimes our goal when we're dealing with projectiles, we have to have two different equations. So, if say you're throwing something up, projectile up at an angle, so let's see, we're shooting, I don't know, a rocket at, let's say, 25-degree angle and at 20 meters per second. And we want to know how far will it go. So in physics, what we have to do is figure out the horizontal and vertical components of it. We figure out how fast it is going horizontally and how fast it is going vertically. I don't know, did we? So, yeah, the goal was we need two separate equations. And this is what parametric graphing is based on, having two separate equations. So, if we were doing this one, I'm just going to do general form, something like this. Negative 9.81 t squared plus 12t plus 15. This says we're going straight up and down based on t. This is the projectile motion formula. You don't have to know it. You don't necessarily have to write it down. It's just an example. So this tells us we're going to go up and down based on t. How long it's been flying. But this does not tell us anything about any horizontal motion. So to get horizontal motion, we have to put another formula. T is time. When you're talking about projectile motion. Now, if we wanted for horizontal motion, we have a second formula. That says for every second, we're going to go like this one is 4 meters per second horizontally.
What is the number for y?
Well, this is the acceleration due to gravity on Earth. This is original vertical velocity, and this is initial height. Yeah, you don't need to know that. I'm going to show you that when we're dealing with physics, projectile motion, we have to deal with two different systems. One is the object's going straight up and down. The other is going sideways. And we have a nice method at the end of that, and that's using parametric equations. So when we deal with parametric equations, we write in the form x equals f of t and y equals f of t. So each one of them has its own equation, where t is your parameter, or parameter. And often we want to put a restriction on the parameter, say maybe t goes from 0 to 15. The variable that we're going to be working with, the one that's going to be changing. So I'm going to get you an example of this. So this is general outline. When you deal with parametric graphs, we have two separate equations. One for this should be g. Two different equations. Makes more sense that way. So let's do a graph. Let's say y equals, let's say 2t, and x equals negative 3t. And our goal is to graph this parametric equation. And let's just say t is included in, let's go with negative 2 to 2. What do you expect the graph to look like? Okay. Now, when we're dealing with parametric graph, we have 3 variables instead of just 2 variables. T, x, and y. So t has a range of -2 to 2, so I'm just going to put these in and we can test them. If I plug in -2 for t, what do I get for my x value? 6. If I plug in that, -2 times 3, or times -3. What do I get for y? -4. So this is 6, -4 would be my point. If I plug in -1, what do I get? 3 and 2, so I get a point. 3, -2, right there. What do I get for 0? So 0 and 0. Not 0. Okay, if I plug in 1, what do I get? Okay, -3, 2, and for 2 I'm going to get -6, 4. So -3, 2, -6, 4. So what does it look like? So in this case, we got a straight line, went from here to here. Now, direction is important. We go from where t is from lowest to highest. So when you're graphing parametric graph, we put direction arrows to say what direction was t increasing on. So we started with the lowest value of t, which generated this point over here. And we went to the highest value. So when you're graphing parametric graph, every time you need to put direction arrows. We went from t equals -2 to -1. So we went from lowest value of t to highest value of t. Remember, right here is our lowest value of t, which generated this point. And so we went down from low to high for t until we got this one. Does that make sense? Okay. Now let's do a bit more interesting one. Say y equals, say, t squared minus 3, x equals, I don't know, let's say 2t minus 1. What do you think it's going to look like? Okay, parabola. Let's say t values goes from, let's say, -3 to 3. So, if t equals -3, what is my coordinate? No. If not, if it doesn't, then you just assume it's every number, and you would just need to put the arrows in continuing on, but also the direction arrows. So if I plug in -3, what do I get? -7, 6. The -7, 6 would be about right there. Okay, if I plug in the -2. Or -5, 1. -5, 1. Everybody see where that came from? Okay. If I plug in, say, -1. Okay, -3, -2, so right there. If I plug in 0, -1, -3. So far, so these predicted to be a parabola. It's starting to look like that. Okay, if you plug in 1, what do you get? Or 0, how about it? Oh, we already did 0, so 1. So 1, -2. So these 2 points are symmetrical, so betting the next one is going to be symmetrical with there. And then, let's see, up here. Okay. Change out the arrows and stopping. Okay, what's the direction on this? Okay, it is going to the right. Because when we went from t equals -3 to 3, then we went from left to right. Okay, and agree with me on how we did that. Okay, now, your calculator can do this for you. So, get your calculator out. We're going to change the mode on your calculator. So maybe you might not have done this setting before. Hit mode. No, here we're saying function. We're going to change it over to parametric. So hit mode right there, and then go down to function parametric, change it to parametric. Okay, once you do that, go to Y flow. Do you notice something a little different from what we had before? Okay? It says x of t and y of t. We've got two equations. So choose some equations, put it there. And note, if you put this back in notes before, what did this give us? X. So if you notice now, it's giving us t. So put some equation in. So I'm going to do t to the third, and say negative t squared. I don't know what it's going to do. I just put negative t squared, I think. Yeah, this one. So I'm going to get this one now. Now I'm doing t mode. Is this supposed to be now? Okay, so now look at your window. What do you notice here for t value?
It's what,
Before it had x's, like x minimum, x maximum. Now we have a set value for t. And x. And y. Go down, it's got the y. Now, one thing you need to be careful of is this t step. Okay, you remember what my graph looks like here? I'm going to change my t step to a little different and say maybe 2. What do you know it's different? A graph is much, much faster, right? However, it doesn't have the same curve. So this t-step value tells you how often to plug a number in to see where the coordinate's going to go. So if I put it as 0.01, it's going to take a lot longer to graph. However, the graph is generally more accurate. A lot longer to graph. Because now it's plugging in every 0.01, 0.02, 0.03, and so on. Whereas when I do it this way, if I put in 2, how many numbers is it actually plugging in? -5, -3, -1, 1, 3, 5. That's it.
Why does that change it so much? Like,
Calculation power. I mean, you're only plugging in, say, 5 points versus plugging in 10 million points, or whatever, not 10 million, but 1,000, say 100 points to 500 points.
but you're still drawing the same line.
Yes, but how does it know where the line goes? By calculating where those points are going. Yes.
But mine looks like different now.
Okay. Yeah, and it will look a little different, yeah.
What is the graphic really about?
Okay. So it could be that your scale is not set up the same or it's wrong. Let's see.
Mine has moved now.
Now what do you think is going to happen if I put something like sine in here? Sine of t. And let's just do cosine t.
Can you both equations?
You do need the equation. You can't graph parametric with only one equation.
Why are we going so fast? I don't know how to do.
Let's make it 5. Let's make it bigger. So, and also, if I know I've got this big space, if I change this down to, say, 0.1.
I don't understand why mine moved. Because I changed the step.
I'm not sure. I'd have to look at it. Now, some of what's going to ask you to do is change between rectangular form and parametric form. So if we said x equals, let's say, 3t plus 1, y equals 4t minus 7. How would I change this to rectangular form? Okay. What's my goal if I'm in rectangular form? What does my equation include? And y. So okay. So did you hear what she said? Get it to equal t and replace the t. So using a substitution. So we're gonna take this first one and solve it for t. So x equals 3t plus 1. Subtract 1, x minus 1 equals 3t. Divided by 3. The t equals x minus 1 over 3. And now I can take that, plug it in here. Y equals 4, x minus 1 over 3 minus 7. Yes, but remember your goal typically is y equals something. And so it's going to be easier. Now, you have to watch domain and restriction. So if there's a restriction on t, we have to make sure we keep that intact. So maybe this one said t is greater than 0 for this. We would have to make sure we keep that intact down here. But these two should graph the same as this one in rectangular form.
Wait, so that's the answer, that y equals
Yep, right here. It's probably better to write it as y equals 4x over 3 minus 4/3 minus 7. Let's combine these. 7 times 21 minus 25/3. Alright, because this part right here, the 4x minus 4 over 12. 3 minus 7, because this part right here can be combined with that. Because it can be. They're like terms. They're like terms. And what about changing it from a rectangular form back to a parametric form? Now, there's easy ways to do it and hard ways to do it. And I think your book tells you to do it not the easiest way. So if we want to change this into parametric form. Now, the easiest way to do it is this. X equals t, y equals 2t squared plus 5t minus 7. Yeah. That's the easiest way to do it. However, it doesn't, it's also sometimes say, you can't do that. I think for the problems they'll say don't use just x equals t or something like that. So how would you do it? Okay, so what if we did x equals 2t? This would be different. So now, how would this change what I have here? We would want to probably solve this for t. Or we actually plug this 2t right back in here. 2t squared plus 5 times 2t minus 7. So, does this part become 8t squared plus 10t minus 7? Does this, well, it would be this one and this one, so those, yeah, that would be your parametric form. So changing back and forth is relatively easy, right?
So when
You could use 2t or 5t minus 8 or 15t plus the square root of 8, whatever.
What was that hard way that the book?
Well, hard way is just trying to come up with something nice that will just cancel this out. So for example, I could say x equals square root of t, and this first part's going to become, let's say, t.
Yeah.
Yeah, so we have y equals 2t plus 5 root t minus 7. So, but it'll work. But the thing is, you do have to make sure, keep in mind, what restrictions are in place.
So the one that you're teaching us to have more room.
Yeah, typically you just choose basically some value for t, or for x, and plug it in, and then simplify it. Either one will work.
Is that it?